Okay, outstanding, gentlemen. Just pick this one up here and start moving pieces around. Inside of the kids' classroom. Okay, so for me, let me build you out some backlog here. I've been working on the Schrostringer substitute teachers class for Bones here and Salty. This is Bones' book. If found, please return to any Salty. You can just go ahead and drop this off. It'll find its way. You've been eating Glenn Farrell. But we'll get into what the art class demonstration is here, how it's all one subject matter under English or cuneiform or whatever you're dealing with as far as the perspectives, the points, how you're analyzing, again, the art perspective. Drawing up cubes every day as a substitute teacher is something to do while teaching them some of the vocation that's necessary in the math problems. They're just drawing, right? And then, maybe you get good with that with a couple of kids and ranges, or you figure out where your kids and ranges are so you can actually kind of pass through some of those stuff between Salty and me. Either way. Anyways, that'll be your pillar, your piece. We're going to switch that off into the baseball coach team. And this is not all baseball coach team, this is also a review subject. What, as a baseball coach, not knowing that but needing perspective, do I have to then find to recreate some of the drills and training examples inside of there that's necessary, and you want to dominate that first interview by what it does, because now it's going to be some level of FMA, throwing the ball, some organic chemistry, which we're going to get into in a minute here. Very simple models of the ASVAB or NP problem of how complicated you want your algebra nuclear soup to be, as far as a time dilation over the course of a day, slipping that art class back into the teacher's design, or figuring out in the teacher's design how to slip one of these in there as far as the perspective, readjust A, B, or C, or what models may be in there to get it to where it needs to be as far as the classroom. And that's an important skill. Baseball coach is the same way, whether I'm dealing with 50-foot, 60-foot, 70-foot fields. Realistically, I should be able to invert pilot theory. I'm dealing with some kids, or actually somebody that's either at the level of high school minor leagues by the grammatics of physics and tabby stars and supermassive black holes. Some kids are going to do better on that 50-foot field, and some are going to do better on the 70-foot field, and of course major leagues. In explaining this subject matter is what I'm looking for as a coach, with the parents, with the kids out there in the classroom. And again, some of your drawouts, let's take some of that ideal of what it is and make sure we're replicating. Some of the best books that we know today actually have some of that ability to absorb the information that way as well. The pitching rules, you're going to go through that nut and bolt. You're going to try to keep in mind your subject space, not go over the material here, because this helps you condense down the timeline a little bit. The blinky winkies we'll get into in a minute. Again, that's some of this for the parents about what you'll actually be doing, whether in a classroom or as a coach. For the rules of the balk, right? You're set and get ready there. Coming to set, or the balk rules, about what the coach should be looking for there, of things that aren't really real but real. They make for an issue as far as trick plays and things like that are well within the rules, as somebody slipping and doing something or manipulating the system in such a way that it's not acceptable. And again, you'll find those drills in life, whether it be throwing a ball and people paying attention, or if that's any other subject matter, teaching the classroom, coaches or calculus teachers, chemistry teachers. It's still the same. You got to throw a ball exercise somewhere's in there, whether it be logs or homework assignments, or describing the entity, which we'll get into in a minute. Different forms of that, again, players, the names, after certain subjects of actually seeing them run around. Why does it make calculus sense that your kid can't be the pitcher, or the supermodel, is because these require works, and actually it's a multi-domain thing of trying to win trophies, and doing that, because that's what that is. It helps you figure out that you're making the right decisions, IH, to adjust whatever packet or unit that you have to be able to do that. And that's going to get us into gym class, because even as art there, the same timeline it takes to figure out what class it is or what element it is. And here we're doing gym's class as a kicker under the ball in itself, picking up something heavy, being exercises from mass, hydrogen 1.0078 to your UUO element 118 on the periodic table. I think 115 is 20 calcium and plutonium. You add them together and that makes 115. by and how many combinations of times you got to actually do that. Amounts and proportions, space time, ball in itself, is it a rock of an ounce? Are we stabilizing it at that point to kilograms? What language are we speaking at mass, under, over? And there's rocket ship experiments and FMAs to deal with gym class of how to run or how to throw the ball. Again, we're looking for the strike zone with the umpire and anybody else in the room, the batter, the catcher, and the photons and the gluon. Catcher in the rye. Bunch of posers. Biomechanics here, how to walk. And we're going to take that arbitrary out later. That's not really for this. This is not really a writing. You don't really have to do this, but you're really trying to break down your mechanics and really be able to see how to walk, how to throw a ball. Is there a smoother motion? Is that observationally causing friction or heat in some way later? And those are going to be relative time frames, prime and unprime. So remember, I'm sprinkling some stuff in here. We're moving real fast to the projectile momentum equation as far as throwing a ball in a weak force. Some of us are not going to be able to do that, but some of us want to be able to still play baseball, right? Still want to be able to be a gym teacher or capitalize on a way that those hold on one second here. That those Molinovic cycles of the sun and stuff for the shoulders on the axis there are actually adjusting in such a way that it's making the right wave function as you can do this and breaking down that cosmic radiation background or radiation background as it would be baseball would be in the form of their points or throwing jump rules. They would have very different structures even though they're same basic mechanics, right? Now I'm learning how to walk and run and really distinguish that there's a difference between what actions are happening there at those speeds, and therefore it's going to require different FMAs. They'll still be FMA. They'll still be you running in a field, jumping, and somebody graphing you that way instead of the rules for the long jump in itself. And we'll get a sand pit and get it going out of us how much in that packet, and then you would generally know if a group around you or something like that. And that's that gym class too, because it's the romper room really, and cleaning the pit after all this stuff. I think we're lined up here. So now we're starting to get into it shouldn't matter jump in, throwing a shot put. You make rules. It's the same calculus graph with the students inside of that system. What we get into, well, we'll just leave it up there. It's working. The history class timelines of these long jumps between every 1,000 years, a millennium for humanity, where it kind of puts us from the Ottoman Empire as a post to put on the farm. Some things you'll see, it's the topology of Earth is still the same at that rate right there. Things didn't move around too much with Pangea, but the computer tech and everything else in the last 1,000 years or so been pretty wild. Then you'll take it back to 1,000 to year 0 BC because that's fun for everybody in history class to kind of get into the flint and steel, Bronze Ages, and all kind of Roman period. Then you're going to make your bigger jumps into older societies. Very old one. What do we got here? The late period, the Paleo. I don't know. Intermediate period, the third intermediate period, and this will take back to really kind of giving you a good fixed timeline as far as where the pyramids were, how you want to do that. Now, remember, these are all active classes. We're gonna hit one of the topics. A lot of information on what this thing is right here and how you'd have to start from here and go back and actually have something back to go work with to go get this, because that's going to be a lot of general relativity in its field. The FMAs or the F or A correlates to this jump that you got to make as far as the analytical write-outs. We'll get into history class breakdowns later, and it's a jump. On a different time scales, that looks very different. You could have the same structure with old Salty Kong out there for the last million years, evolution of the Lucy here, and how if you actually look at the Stone Age and the tracking of arrowheads of the Clovis people and stuff like that back, well, their Clovis is like 11 BP, so it means like BC before that timeline. Realistically, starts to jump back before you get into the millennium levels of it. Where Lucy's skull is 5 million freaking years ago. That's a long time for the evolution of this thing. A couple of cultures we're gonna have it figured out from just Lucy standing upright, evoluting as she do. up to what kind of culture models would correlate to its branch down evolution as those things crossbreed, change territories, boat around inside here, and how the evolution of the salt to the sponge, somewhere's in that neighborhood, to the sharkies, and everything else that are on that type of scale. You would need a shelf on the bookshelf there to deal with some kind of evolution that works in very radical timelines here. They're 1,000, a million, and and inside what would actually be the billion ranges is something that you need at the CMB level, which could actually be talking about elements that take seconds to describe. Yes and no, they worked. Or how we have to stop and deal with that for 3 minutes or 5,000 years because that's what the elements are actually provided when we actually do what element we're throwing, right? Because this will be finances later at more advanced levels in the class, not necessarily a kid, but a coin can be any coin, right? And you can design energy like that. That gym class is where they need to make the marshmallows up as far as weights on the plate. And that's your CMB. That's that element decay, hot plasmic nuclear soups for a second or two talking about it there. But over 3 or 4 minutes, it'll start to temper out. And then, for the next 5,000 years, it'll kind of be in that neighborhood of banging around with other elements that are close or orientated to around it. The Ottoman period, we'll actually get into some of the write-outs of the first jump back here. Something good. Turkish army, their expansion was nice and clean. It goes in with the evolution of King Kong over here, moving his way, turning into the White Devil for a little while, and doing the whole Sharps thing. Because he comes from Africa, and then you track that around by virtue of the archaeology, real science today, photons and stuff that get in the way of some people's crap or period and models. When it comes to the book is the beer. And again, so the Ottoman Empire is a way to kind of culturally understand it. We'll get more into that here in a minute as far as the Agrestia, Ergaster period of humanity. And again, this is the working man, the stone men, for where it was in the evolution, kind of some still criminal with sloping foreheads like the rest. You can tell we all got it. And what it may be as far as stone tools, what kind of cultural models, little groups, which we still have today. There's still a gravity calc to it that's real important for the working man inside here that describes, that's that action, basket weaving, some IKEA build, their jump shelf build, book. We're going to get more into that later, but we're